Here we're asked to find the slant asymptote of this function. Now we get a slant asymptote whenever the degree of the top is exactly one more than the degree of the bottom. So when the degree of the top is greater than the degree of the bottom, we said there is no horizontal asymptote, and that is true. When the degree of the top is exactly one more, there is a slant asymptote. And so here the degree of the top is 2, which is one more than the degree of the bottom, which is 1. And so we do have a slant asymptote. The way that we find it is to go ahead and carry out the division that's indicated by this fraction. A fraction is essentially a division problem. So depending on the actual function that we're given, we may need to use long division. In this case we can use synthetic division, or if it's just a single term there on the bottom, you can just go ahead and divide each term on the top by that. So the actual division may vary from one problem to the next, but we need to divide in order to find the slant asymptote. The equation of the slant asymptote is going to be y equals the quotient part of that division, so everything but the remainder. So we just leave the remainder off, and the quotient part there will be the slant asymptote. So because of the way this one's set up, we can use synthetic division. We would put a 2 in the box and set up our coefficients. And go ahead and go through the synthetic division process again. The remainder does not become part of the slant asymptote at all, and so our quotient part here would be 2x minus 1. It is starting as an x to the first power because our original polynomial on top was an x squared, and so we go 1 less than that. And so our slant asymptote is the line y equals 2x minus 1. So we just use that quotient part of our division.